The function f is continuous on the closed interval 2 to 13 and has values as shown in the table above. Using the intervals 2 to 3, 3 to 5, 5 to 8, and 8 to 13, what is the approximation of the definite integral from 2 to 13 of f of x with respect to x obtained from a left Riemann sum? The first thing that sticks out to me is that this is a left Riemann sum problem where I'm approximating this definite integral. The next thing that sticks out to me in this problem is that I'm given the intervals that are going to be used for each of the rectangles in my Riemann sum. So I know we don't have a graph here, and we're not actually going to be drawing rectangles because of that. But if we visualize what this table is telling us, then we can use that visualization to understand exactly what the area of each of the rectangles would be. So let's just start with the first interval or the first rectangle that we're going to find, which would be the interval from 2 to 3. So I'm looking at my table on the interval from 2 to 3. So again, we don't have a graph, but it can be helpful to visualize a graph or literally draw a graph if you're confused. We're starting this interval at 2, and we're ending it at 3. There's another interval 3 to 5, another interval 5 to 8, so on and so forth. But just looking and focusing in on this first interval, I can see that I'm going to have a base that is the distance between my x values. So the distance between 2 and 3 is just 1. So using base times height, right, the formula of a rectangle, I know my base for this first rectangle is going to be 1 because the distance between 2 and 3 is just 1. Now again, calling in the fact that this is a left Riemann sum, if I want to find the height of this first rectangle, I need to look at the left endpoint. 2 is the left endpoint of the interval from 2 to 3. 3 to 5, 3 would be the left endpoint. 5 to 8, 5 would be the left endpoint, and 8 to 13, 8 would be the left endpoint. But in this example, 2 is the left endpoint. So we're going to be looking at the function value at 2, which is 6, to find the height of this rectangle. So this first rectangle has a base of 1 and a height of 6. So the total area of this first rectangle is going to be 6. The first rectangle has an area of 6. Now let's move on to the next interval. The interval from 3 to 5 is where we're looking on this table, and I'm going to draw a graph again. If you need to draw the graph to help you visualize it, then please go ahead. But if you don't, then you can go ahead and just do this math in your head. So I'm looking at the next interval. We did 2 to 3. Now I'm looking for 3 to 5. And I know that the base, again, we're looking base times height because we're creating rectangles. The base is going to be the distance between these two x values. So the distance between 3 and 5 is 2. So my base for this rectangle is 2. Now for the height, again, I'm calling attention to the fact that this is a left Riemann sum. So we're looking at the left value in this table, which is 3. And f of 3 is -2. That means the height of this second rectangle is going to be down here at -2. So overall, this area is going to be a base of 2 times a height of -2, which is -4. So this means our first rectangle has an area of 6, our second rectangle has an area of -4, and I'm going to send you back into the lesson so that you can find the area of the last two rectangles and find the ultimate answer of this Riemann sum approximation.